Okay, so it's time to examine all of the Pearson correlation coefficients between our variables to see how they're all related. The problem is we can only calculate the correlation coefficient between numeric variables. So some of these we can change and still use, and some we can't. So marital status. Now, it'd be tough to call married a 1 and single a 0. It implies one is more than the other. Uh, However, how many different possible marital statuses are there? We don't have divorced here, there's only two. So this is a dichotomous categorical variable. So we can actually convert this into zeros and ones and use that since there's only two, we can do that. If there were three variables, then that would imply some type of order, which we couldn't do. But since there's only two, we can convert these to zeros and ones. So what I want you to do, copy this original worksheet. Let's make a new one where we turn all of our variables into numbers to the degree possible. So right click, move or copy. I'm going to create a copy, okay. Okay, not sure what that means anyway. Let's change this name to, whoops, undo. Let's change this to numeric. Excuse me. Let's go ahead and do a find and replace here, and let's match whole contents. Let's find married, replace it with a 1 only because married typically happens after being single, no other reason. Replace all, okay. Change single to 0, replace all. Got it. And of course it only did that here in this column where I selected the entire column. So let's continue this onward. Male and female. Okay, same thing. Because there's two values, we can recode it as a 0 and a 1. Doesn't matter which one we use for which. So let's say male. Since I already have 0 there, I'll leave it. Replace all. Okay. Female. 1. Now I need to remember that we changed male to 0 and female to 1 when we interpret these analyses later. Alright, let's keep going. Education. Now this one's a bit different. There is an order to education because, for example, partial high school is less than high school is less than partial college college less than bachelor's less than graduate degree. So I'm going to say yes, let's go ahead and convert these to numbers, 1, 2, 3, 4, 5, but we need to beware a little bit. By changing it to numbers, we're implying that the difference between number 1 and number 2 is the same as the difference between number 2 and number 3. For example, is the level of education difference between someone with a partial high school degree and a full high school degree the exact same as the difference between someone with a high school degree and a partial college degree? Probably not. However, there is some order involved there, so most people will justify going ahead and replacing ordered categories with numbers. So partial high school is the lowest. Partial high school, we'll change that one to a 1. Okay, high school, let's change that one to a 2. Okay, partial college, 3. Bachelor's, 4. And lastly, graduate degree, 5. I must have spelled it wrong. Yep, I sure did. No S, degree. Okay, so that field's ready. How about occupation? Well, we learned in a previous example that certain occupations make more money than others. However, we already have income right here. So I don't want to order occupation based on how much money they make. I'm going to say that there's nothing we can do to change this to something numeric, so we're going to have to ignore that one and leave it as is. Homeowner, however, though, that's a simple yes, no. Let's change yes to 1. Since this is dichotomous, we can do this. And no to 0. Replace all. Okay? Commute distance, also definitely an order implied. So I'm going to copy 0 to 1 miles and make that a 1. Replace all. Okay. 1 to 2 miles is now at 2. 2 to 5 is a 3. 5 to 10 is a 4. And I believe there's a 10 plus. Let's take a look and see if we can find any. Oh, maybe not. Oh, yeah, there it is. 10 plus. That's now 5. Okay, how about region? Clearly no, right? There's no order to this. We can't change that. We're not going to be able to use it for this analysis. Purchase bike, definitely. Thankfully, it's a yes, no. So we can change yes to a 1. And no to a, no to a 0. Replace all. Okay, close those out. Control S, save my new data set. And let's do some rearranging to make our calculation a little bit easier. I'm going to move occupation out here, and I'm going to move purchased bike in here. So what I've done is I've made all of my numeric fields that I can calculate a correlation table on consecutive or grouped together. Okay, next step. Now if you don't already have, if you click on your data tab, and if you're like me and you don't see an option here for solver and data analysis, you're going to need to go click on File, Options, click on Add-ins. Wait for it, it's kind of a slow one. Down here you'll see Manage Excel Add-ins, click Go. Click on Data Analysis Tool Pack. I'm going to go ahead and check Solver. You won't need Solver for this demo, but I'm going to use that for later. So I'm going to hit OK. Give it a second. There we go. All of a sudden, Analysis pops up with Data Analysis and Solver. If yours didn't pop up, okay, save your file, close it, reopen it, and it may show up then. And if it still doesn't show up, go through that process one more time of trying to add it. Sometimes it takes Excel a couple of tries before it holds. Anyway, once you have it, go ahead and click Data Analysis. It pulls open this box. Click on Correlation and hit OK. Now, this box is it's not quite as user-friendly as you'd like. Every time we want to input a range, make sure you've clicked on the proper text box. I'll show you what I mean. So with your cursor blinking here on input range, I want you to come back here and select and include the labels marital status through purchase bike. Hold down Control Shift, hit down so it selects all of them. So you should see B1 through K1001 if you formatted it the same way as mine. Check the box labels in the first row because we included the labels. Click Output Range. Now this part's important. I can't simply collect on the cells or it's going to overwrite my input range. Click here on the Output Range box. It's annoying, but you have to do it. And just find something over here out of the way where we want to print out the results. I'm going to select O2 and hit OK. So give it a second. It calculates and comes up with this table. What we have now is a table showing the Pearson correlation coefficients for each pair of variables. Notice along the diagonal we have 1s because it's showing the correlation between marital status and marital status, gender and gender. Okay, so we're plotting the exact same variable on the x and y axes, which is why correlation is perfect. It's 1. A 1 unit change on marital status results in the exact same 1 unit change on marital status. These ones are blank because we already have the correlation coefficients down here. Gender to marital status is right here, so we don't need to repeat it right there. That's all. So I'm going to give myself a fewer decimal places. I don't need quite that much precision. There we go, that'll do. I'm going to shorten or move those a bit closer together. So let's just take a look at these and see if there's anything that's surprising or jumps out at us. Alright, so for example, let's choose this one, home ownership and income. That's one of the ones that surprised me a lot. 0.02 is a very, very small correlation. Again, it doesn't matter if it's negative or positive, it just matters that it's close to 0. In other words, it's very weak. The line of best fit that would be drawn through the scatter plot of those two variables would be, the slope would be very low. Let me show you visually what that means. I'm going to come over here and select homeowner and income. Let's see here, homeowner and income. And I'm going to insert a scatter plot. Okay, homeowner, there's only values of 0 and 1, so it's only going to be on one of these lines. But what my point is here is you don't see a lot grouped over here and then a lot grouped down here on the right hand side, or vice versa. You don't see what I would have expected would be a lot of non-homeowners in the lower income range, so a lot of dots here, and then a lot of homeowners in the higher income range, so a lot of dots up here. But instead, they're kind of identical. They have a bunch of people down here, and then some gaps, and only a few people who own homes or in the higher income range. There's really no difference between this line and that line. So if I were to add a trend line to this chart, add trend line, that trend line is almost perfectly straight. Now it's not perfectly horizontal, but it's almost horizontal. As a result, right here it is, my correlation coefficient, well, it's not the slope that determines that, but basically there's not a clear set of pattern to the dots. Now let's find one that's opposite. What's the biggest one you can see here? How about age to number of children? That kind of makes sense, right? As people get older, they have more kids. That's the highest one on the board. Let's plot that one and see what it looks like. So here's children and age. Insert a scatter plot. Here it is. Okay. Now you might look at this and say, well, it's not a very strong correlation, but actually, yes, you can see 0 children. It's clumped together down here under the smaller age. Now, yeah, there's definitely a lot of variance, but as we go to more and more children, you can see the median is sort of moving up all the way along. Add a trend line to that. So again, it's not the actual slope that matters, but the strength of the, or how well these dots group around that line as it goes up. Okay, delete that one, head back over here. Here's a trick question for you. What is the stronger correlation? Education to purchase bike or purchase bike to commute distance? Okay, hopefully you answered neither, they're the same. So both of these, 0.14, it may seem like small correlations to you, but in practice, a 0.14, if you have enough data, is very likely to be statistically significant. Now there's that word again. What does it mean to be statistically significant? Now I haven't tested for it right here in this chart, but statistically significant means it has something called a p-value that is less than 0.05. What that means is that if something's less than 0.05, it means that there was less than a 5% chance that this happened just due to chance. So, or you could say there's a 95% likelihood that there really is a relationship between the two variables. So who came up with p equals 0.05? Well, over time scientists have sort of decided that's what they've arbitrarily decided. That's what they think is defined as being statistically significant. So there are other tools that will actually show you these correlations, and next to it in the box put a p-value so you can see, hey, it's 0.53, but did we just get that due to chance, or is it very likely that there really is a relationship between age and children? So that's our correlation table. Things to remember. Correlations range from -1 to 0 to 1. So weak correlations are those that are close to 0 from either direction. Strong correlations are closer to the endpoints here of 1 and -1. Remember, we can't do correlations with categorical variables. We change things to numeric wherever we can, but we're limited. We need to find something to do with these categorical variables. Also, we don't know for sure if a correlation of 0.14 which seems small relative to some of these other ones, is that still possibly statistically significant, even though it seems small? Can we say that this correlation between people who are more educated buying bikes from us is something that is not due to chance, but there truly is a relationship, meaning that people with more education, since this is positive here, that means people with more education are more likely to purchase a bike. If we could find that out, that would be super useful, because then we could create advertisements, mailers, commercials that target people that are more educated. But if that's not statistically significant, then maybe we don't care and we don't want to change our advertising. So this is what the correlations can do for you. Let's move on to ANOVAs.